Hello, my name is Brian Cooper. And just to remind you of who I am a high school teacher in the school district of Philadelphia, and I teach high school ninth and 10th grade biology and chemistry. And this is my presentation on my reverse engineering project. And the device I chose for this project, it was a stapler. In this diagram, this is a stapler that I disassembled. And these are the different parts of the stapler that I was able to identify. The base is at the bottom, metal axle, it's a hinge, top plastic cover, and this crimp area. And when it's unfolded, you can see where the hammer, the magazine, the pusher, and the anvil are located. So what is the purpose of this device? A stapler is a mechanical device that joins pages of paper or similar material by driving a thin metal staple through the sheets and folding the ends. The fastener, called a staple, is a two-pronged shape that's usually made of metal. When pressure is applied to the stapler, it drives the staple through a stack of paper, which holds the prongs down to create a firm binding. So, what is the purpose of the shape? It is shaped to be handheld and to be used single-handedly. It is designed using simple machines. It's made with a lever, the handle, a wedge, the staples, a wheel and axle, the spindle point for the lever, and the inclined plane, the slant for papers to slide up below the staple dispenser. Another reason is for ergonomic and reduced effort. So the way that it's designed requires less force to push the staple through the stack of papers. Weight and color relevance. It is lightweight for easy transport and handheld ability, and the color is just to be visually appealing and for aesthetics. So here is the stapler disassembled to the best that I could, and I labeled each area, each piece, the best that I could. And so what I was able to determine was that the materials that make up the stapler were mostly metal and with some plastic. The components that are metal are recyclable, sturdy, easy to shape, and low cost. The components that are plastic are easy to shape, are low cost, but unlikely to be easily recyclable. So, component analysis. So while taking apart the stapler and looking at the different pieces, I was able to identify what each piece was, and I was able to infer what the engineer who designed it or created it had in mind when making each piece. So piece number one, it's the cover area it's the area to push down. Piece number two is the base, which provides a surface for papers to be stapled on, and then staples to stay in place. This metal part right here on the base is the crimp area, which allows to manipulate the staple. This metal piece number four is a sliding house top, which keeps staples contained during use. Piece number five is sliding house bottom, and it is a surface for which the metal slide and the staples to sit on. Part number six is a rod, which goes into the spring, which is part number seven, which is the spring, which provides tension and movement to the metal slide in order to keep staplers in the correct area for use. Piece number eight is the top cover, which allows the user to have more comfortable way to staple and makes staples more aesthetically pleasing. The stapler more aesthetically pleasing. Part 9 is the bottom spring, which allows the stapler to bounce back to original position after stapling. Part 10 is the staples. These are the things that are bind papers together. Item 11 is the pusher. This ensures that staples are always toward the front of the slide during use. Piece 12 is the top tab. When pressed, it pushes the staple down through the slide housing onto the paper to be stapled. Piece 13 is the axle, which allows the stapling mechanism to hinge from the base. And piece 14 is a rubber insert part of the base, which keeps the base from slipping and moving during use. So, ease of use in manufacturing. It is handheld, lightweight, can be used anywhere, so there's no need for a power source, can be used for tacking, and seems to be easy to assemble and manufacture. Competition and criticisms. This model looks to be cheaply made, which could result in jamming. It was probably not designed to have a long lifespan. Other models may be made with heavier duty components, making it durable and last longer. Suggestions for improvement. A better stapler could be automated, could staple large quantities of paper at once, can be used in rapid succession, and designed to not jam. Some additional insight. So when looking at the different pieces, I noticed that there was a hole at the bottom that allows you to push in and rotate the crimp area. This metal piece on the base, the crimp area, this area bends the staple into place. The plate can be adjusted for standard permanent stapling or temporary stapling. And then I also noticed that there is a little dimple right here in this piece attached to the base. And what I noticed that is that this allows the sliding house bottom to stay in place. Kind of acts like a little hinge. It's indented. Okay, so that was my reverse engineering project, and I hope you enjoyed.